Hi there, I'm Bethany Moats. Welcome to the Kامsól series of post-processing tutorials where we show you how to utilize the wide variety of post-processing tools that Kامsól Multiphysics has to offer. Now finally, I'm going to show you a fun little trick that allows you to display a periodic array when you've only solved for one periodic Unix cell of your model in Kامsól. So to demonstrate this, again, I'll choose View, Model Library to open the model library. I'll go to the RF module here, and I'll choose Optics and Photonics, and choose Plasmonic Wire Grading, and open model. So this is a model of a wire grating, where there is an incident plane electromagnetic wave coming from the top boundary here, incident magnetic field. But in this case, instead of modeling the entire grating, we've modeled just one unit cell of the grating with just one bar shown here. And then in order to specify that this is a periodic array of these bars, we've used this periodic condition on both sides of our model. Now in the results, if we look at the TM wave here, we'll see the results plotted on this unit cell that we've modeled. But maybe we want to get a better idea of how this incident wave is going to look like as it approaches the entire grating. So in order to do this, first we'll go ahead and turn off this plot dataset edges to eliminate those black lines around the model. And then we'll look here. We see we have a surface plot of the electric field norm. So we want to create a copy of this plot and tessellate that out horizontally. So in order to do that, we'll go ahead and right-click on the surface plot, choose to duplicate this plot. But on the duplicate, we'll want to make some changes. So first of all, we're going to want to turn off the color legend. We don't need two of those. We'll go ahead and turn off the title. And then we need to move this plot over by a distance of the horizontal thickness of this geometry. So in order to do that, we can add to this surface plot a deformation. But instead of using some kind of physics calculation to define the deformation, we'll go ahead and make this a constant deformation. In the x direction, by the distance d, which in our model here defines the width of our geometry. And then we don't need this to move at all in the y direction, so we'll choose that to be 0. Now if we go ahead and plot that, you'll see that it hasn't moved completely by the distance d as expected. That's because every deformation uses a scale factor here that normally chooses the best scale to display the shape of the deformation. But here we want to deform this by exactly a distance of d. So we're going to choose to check the scale factor and change this manually to be 1. Now if we replot this, you'll see that these two are now side by side just as we wanted them to be. Now we want to add a couple more of these unit cells to get a larger picture of what's going on. So again, we can use a shortcut. We can right-click on Surface 2, and we can go ahead and duplicate this. And now the only change that we need to make from the previous plot is to change the x distance that it's being displaced. Keep in mind that each time this is a displacement from the original. So here we need to define this as 2 times d. And similarly, we'll go ahead and add a fourth plot. So we'll right-click here, duplicate, and change the next deformation to be 3 times d. Now if we plot this and zoom extents here, now you'll see a much better idea of how this wave profile is looking as it's incident on this wire grating. So there we have it. I've just demonstrated how to display a revolution, mirror image, extrusion, sector array, and periodic array of your data. I hope you were able to pick up some new tips and tricks from this demonstration. Stay tuned for more videos in this series that will demonstrate many other post-processing capabilities of Kامsól. Thank you for listening.